Elon Musk and SpaceX have gone crazy. Think about it. How does a rocket company that just had a successful test flight have a new prototype and booster ready for testing within days? If we look at the competition, it has taken years for companies like Boeing, ULA, and Blue Origin to test their rockets. And then there's SpaceX. The company has already performed a static fire test for their newest Starship prototype, the S29, with record-breaking speed after the last test flight. How is this even possible, and how did the test play out? Let's find out. Following a partially successful third Starship test flight, SpaceX is diligently preparing for another flight next month. Elon Musk expressed anticipation, tweeting about the potential for another significant milestone in space history. However, before launching a rocket, especially one still under development, SpaceX must conduct a series of tests. These tests include pressurizing the rocket's tank to ensure it can withstand the correct propellant pressures, checking various systems at the launch pad, and firing up the engines to assess their readiness for flight. The engine tests, known as static fires, are crucial steps in the pre-flight checklist. SpaceX has accelerated its pre-flight testing for the upcoming Starship mission just weeks after IFT-3. They conducted 2 static fire tests for the engines of Ship 29, a prototype slated to participate in Flight 4. Before the test commenced, a notice was issued to alert residents in Boca Chica village about potential health and safety risks. This alert informed them that SpaceX would be conducting a Starship test between 8 a.m. and 8 p.m. on March 25th, aligning with the previously announced road closure schedule. When preparations were completed around noon, SpaceX initiated the process of loading liquid oxygen fuel into the Starship. After approximately 20 minutes of fuel loading, venting procedures were initiated to release excess pressure from the spacecraft. Following this, the engine underwent a chilling process, a critical step before liftoff to ensure optimal performance by reducing temperature differentials between the fuel and the engine. Concurrently, observers noticed a distinct phenomenon as frost began to form and gradually ascend within the fuel tank section. This frost formation is a visual indicator of the extreme cold temperatures associated with the cryogenic fuels used by the Starship. Approximately an hour later, at 1:12 p.m. CDT, the engines were ignited, producing a fiery display that lasted for about 10 seconds. This ignition test is a crucial milestone in the pre-flight checklist, allowing engineers to verify the functionality and readiness of the engines for upcoming missions. Closer observations suggest that the ignition process unfolds in 2 distinct stages. Approximately 2 to 3 seconds after activation, the flames appear to intensify, indicating that SpaceX likely initiated the 3 sea-level engines before engaging the 3 vacuum engines. The fiery display remains consistent with previous tests, boasting a formidable thrust of up to 1,500 tons and enveloping the test stand in a dense layer of dust. This reaffirms the formidable power and reliability of the Raptor engines on board the Starship. Hours after the test, SpaceX shared the achievement on their official page, confirming a full-duration static fire of all 6 Raptor engines for Flight 4 of the Starship. This development signals that SpaceX is edging closer to Flight 4, which is currently slated for early May. Alongside S29, SpaceX still has B11, which is yet to undergo the static fire test. Once completed, the 2 stages will be stacked together to conduct the wet dress rehearsal test. With over a month remaining until the expected launch date, SpaceX is poised to embark on an eventful April at Starbase. Regarding the static fire test with S29, it represents another significant milestone for SpaceX. Remarkably, this test occurred a mere 11 days after Flight 3 on March 14th, underscoring the company's rapid pace of progress and innovation in the realm of spaceflight. The pace of development has clearly accelerated significantly compared to previous flights. For instance, the S25 static fire occurred on June 26, 2023, more than 2 months after Flight 1. Subsequently, the next two static fire tests of the S-28 prototype took place on December 20th and 29th of the same year, with over a month passing since Flight 2 on November 18th. This highlights SpaceX's concerted effort to reduce turnaround times between flights. Elon Musk's recent reaction to a tweet on SpaceX's progress further underscores this trend. In response to a tweet mentioning the shortened timeframes between prototype flights, Musk concisely replied with, "Yeah." While brief, this response clearly reflects his and SpaceX's ambitious goals of continually accelerating the pace of development. The vision is to progress from months to weeks and ultimately to days between prototype flights, demonstrating SpaceX's commitment to rapid innovation and advancement in space exploration. Earlier this year, Musk set an ambitious goal for the frequency of Starship launches in the future. He proposed that Super Heavy flights could occur as frequently as every hour, while Starship flights could happen daily. This represents a significant leap forward in launch frequency compared to current standards. Additionally, Musk previously suggested the concept of launching thousands of Starships annually to Mars, illustrating SpaceX's bold vision for interplanetary exploration. As SpaceX progresses towards these goals, static fires are becoming increasingly routine at Starbase. What was once a notable event in the aerospace community is now transitioning into a more routine aspect of operations. This shift reflects SpaceX's commitment to advancing the development of Starship and streamlining launch preparations. Ultimately, SpaceX aims for Starship to achieve a launch frequency comparable to that of the Falcon 9, which has become a workhorse in the rocket family. Following the completion of the test campaign, Ship 29 has returned to the high bay, where final launch preparations are in progress. One notable upgrade for Ship 29 is the installation of 4 Starlink dishes on the nose cone, similar to Ship 28. This enhancement will provide uninterrupted communication capabilities during the mission. One of the most recognizable activities on board Ship 29 is the repair and inspection of the heat shield. During re-entry into Earth's atmosphere, Starship faces the highest temperatures of the re-entry process. Therefore, it requires a clean, sturdy, and effective heat shield to withstand these extreme conditions. Elon Musk has emphasized the importance of achieving this goal for the 4th flight. Additionally, SpaceX is meticulously reviewing Ship 29 for any necessary modifications, especially in light of the roll issues experienced by Ship 28. Ensuring the structural integrity and functionality of the spacecraft is paramount for a successful mission. By addressing these concerns and implementing necessary upgrades, SpaceX is working diligently to ensure the readiness and reliability of Ship 29 for its upcoming flight. With continued advancements and innovations, Starship is poised to surpass its predecessors and become a key player in the realm of space transportation. Thank you for watching. Please remember to leave a like and subscribe as we continue to count down to the historic 4th test flight of the Starship.